The future of AI is decentralized, but what cryptocurrency is actually scalable enough to handle humanity's go-to AI? Believe it or not, Arweave claims to be the most scalable crypto project with no real scaling limits. In fact, the Arweave chain consistently does hundreds of transactions per second today without breaking a sweat. And with their latest upgrade, which is turning their super scalable chain into a massive supercomputer to run AI on, which actually caused the price of the AR token to triple in a few days, it may have a running chance to be the coin that dethrones OpenAI and takes over the entire crypto AI sector. So that's why today we're going to find out what exactly Arweave is, bring you up to date on their new supercomputer update, and examine just how much potential it could have. This video is not financial advice, read disclaimers on the screen. So Arweave, a decentralized permanent information storage network, was launched by a man called Sam C. Williams. The token came out at the end of 2019, and straight off the bat it was backed by some of the biggest investors in the crypto space, notably A16Z Crypto or Andreessen Horowitz, Multicoin Capital, Union Square, and 1KX and Techstars. But what actually is Arweave, and why did it drum up so much hype from these big names? Well, at its core, Arweave is a global hard drive that never forgets. You can almost think about it as a modern day Library of Alexandria, where humanity can put all of their information on top of it, and that information will never be lost. And that right there is the real innovation Arweave brought to the table: permanent information storage. Never in humanity's history has there been a way to permanently store a large amount of information. Many people say that when the Library of Alexandria back in the day, which had all of humanity's knowledge in it, burnt down, it set humanity back 1,000 years. And something like that with Arweave around is no longer possible. Arweave can never burn down, and it can never lose your information. And that right there also makes Arweave stand out from the other storage coins. So other storage coins work on a rent basis, where you basically just rent out storage. On Filecoin or the Internet Computer or Sia Coin, etc., you need to constantly pay for them to store your data, and if you miss a payment or you just stop paying, your data gets completely deleted. So if you think about it, actually Arweave doesn't have any true competitors, because none of these other storage coins actually offer permanent data storage. Now, just for a second, before I do go into how Arweave works and how they're building a super powerful AI on top of it, just think for a second how big of an innovation that already is. All of humanity's knowledge could theoretically be stored on top of Arweave, and it could never ever be lost. No new government or dictatorship can come along and delete information uploaded to Arweave like we've seen in the past, and like we're still seeing right now on Web 2 with people getting censored, etc. One of the biggest use cases we've already seen for Arweave was when China took over Hong Kong in 2021, and this news site called Apple Daily had to move to the Arweave blockchain. And that is because the Chinese government started banning websites in Hong Kong that it didn't like. The internet service provider Hong Kong Broadband Network said it blocked access to things like the Hong Kong Chronicles, a website offering information about anti-government protests. And that is what led to Apple Daily uploading all of their articles and their new news articles as well onto Arweave so they couldn't be deleted and lost. Another big use case are NFTs. In case you're not aware, the actual picture data for NFTs aren't stored on the underlying blockchain like Ethereum or Solana, because that is incredibly expensive to do because it takes up a lot of data. The only thing that is stored is just a link to where if someone clicks it, they can then find the picture. But if that link leads to a centralized website or a centralized server, then that's bad, because your entire NFT basically relies on that centralized component staying alive. Which is why many NFT projects have opted to host the pictures of their NFTs on top of Arweave. This is very popular for big sets, especially on Solana. And at one point, even Mark Zuckerberg's Meta was using Arweave to store their NFTs for Instagram. If you're liking the sound of Arweave and the other altcoins I talk about on this channel, I just want to remind you that this bull market, some of the top crypto exchanges are trying to give you over 6 figures in bonuses. All you need to do is click one of these links in the description down below. Let's click on the BingX link. BingX is a new gen top crypto exchange. You can just make an account right here, and if you go to the rewards hub, you can see how to claim thousands of dollars for free. The bonuses for BingX go up to $135,000 and that's all money you can use for trades or to invest into altcoins, etc. But how exactly was Arweave able to do the impossible, create a permanent storage network that no one else in history had ever done? Well, let's get into the tech, and there are two main components that allow for permanent storage on Arweave. There's a technical component that turns the blockchain into something they're calling a block weave, and also an economic component that created an endowment that would cover the cost of future storage. So let's firstly understand what Arweave's block weave is. In a normal blockchain like Bitcoin, there is a linear sequence sequence of blocks each containing a list of transactions or data records, and these blocks are linked to each other in a chain through cryptographic hashes, with each block containing the hash of the previous block, creating a secure and unbreakable chain of blocks from the genesis block to the current block. And that right there is how the name blockchain came about, because in essence Bitcoin is just a chain of blocks containing transactions. Another aspect of Bitcoin is called proof of work. Whoever adds the newest block to the Bitcoin blockchain gets a bunch of Bitcoin. And the way the Bitcoin network decides who's allowed to add that new block is by giving out a super complex mathematical problem. And whoever's the first to solve that mathematical problem is the one allowed to add that new block. And that's why on Bitcoin you have these people creating massive mining rigs, so that they can be the one to solve that mathematical problem, and they can be the one to add the next Bitcoin block, meaning they're the one to earn those block rewards. Lastly, on Bitcoin, if you do want to mine it, you do need to store every single block from the present to the first block ever generated. Arweave's Blockweave works a little bit different to Bitcoin's blockchain. Now, it is an iteration of the traditional blockchain design, but it was reworked to enable the permanent storage of a large amount of data. So each block in the Blockweave is linked to two previous blocks instead of one, the previous block and a randomly selected block from Arweave's history called the recall block. And miners must have access to this recall block in order to mine new blocks and earn rewards through the consensus mechanism called proof of access. Now, this recall block is selected at random from Arweave's block history, and this means that if you store more recall blocks, you have a higher chance of being able to create the new block and earn some rewards. So you can see how in the same way Bitcoin incentivizes miners to build huge mining rigs to solve mathematical equations so that they can produce the next block, in Arweave people are instead incentivized to just store more data, because it gives them a higher chance of having access to that recall block so that they can then earn rewards. But also it encourages miners to store rarer blocks instead of well replicated ones, as they will be competing with a smaller number of miners for rewards. So this ensures that no block gets deleted or gets forgotten, because miners are always looking out for blocks that aren't stored by other miners as much. And the last piece of the puzzle here is that you don't need to store the entire history of Arweave. One of the bad things about Bitcoin's design is that you are forced to store every single block going back to the genesis block, and as more transactions are added and more data is added, this becomes harder and harder for people to do. And that is why many blockchains, including Bitcoin, are dealing with scalability issues. Bitcoin can only do 7 transactions per second. On Arweave, although you are rewarded to store more blocks, it's not a requirement, meaning that Arweave is able to grow massively, basically infinitely in scale. And you may be thinking, hey, if everyone isn't forced to store all the transactions like on Bitcoin, does that mean certain transactions could be lost? Well, that is where proof of access once again comes to step in. Because like I said, proof of access encourages miners to store as many blocks as possible, along with rarer blocks that less miners are storing, so that they can be more likely to earn rewards. So that's how Arweave did the impossible to allow for permanent information storage at any scale. They just took a blockchain which already worked and redesigned it, allowing it to scale infinitely in size, whilst also ensuring it's still secure and data is still stored. And in case you're doubting that this actually works, Arweave has been running just fine since 2019 and is currently doing 500 transactions per second as I'm speaking to you without breaking a sweat, whilst permanently storing 158 terabytes worth of data. Now, the second component needed to make permanent storage is an economic component. If you remember correctly, all the other crypto storage solutions force people to pay on a regular basis. You pay monthly or whatever, and if you don't pay, your data gets deleted. Well, straight off the bat, Arweave forces people to pay for initial storage costs for the first 200 years. Now, this sounds expensive, but it really isn't. For $1, you can already upload 400 photos or 3,500 office documents to Arweave. Now, the reasoning for paying 200 years upfront is that over time, storage costs have gone down. Just in the 1980s, it cost $700,000 to store 1 gigabyte, and you can basically do that almost for free now. So the bet Arweave is making is that this trend will continue on into the near future, meaning that the amount you paid for the first 200 years will probably cover your storage costs on Arweave till infinity, because of the fact that storage costs will just keep going down and down and down into the future. Okay, so that's how Arweave achieved for the first time in history a permanent information storage network, which is also infinitely scalable. But after building this, the Arweave team realized something, which is that you can actually use an infinitely scalable storage layer to build an infinitely scalable computer. So introducing AO, the hyper-parallel computer. The first thing you need to realize is that smart contract platforms like Ethereum can also be described as computational platforms, but they're actually much less powerful than many people think. Here's Sam Williams, the creator of Arweave, to explain.
A TI-83 calculator, the kind that you would get in a classroom when you're a kid, does over 5 times as many instructions per second as the entire Ethereum network, with tens of thousands of computers and billions of dollars at stake.
And that's why AO was created, to actually be a scalable computer. But let's break down how exactly the AO computer works part for part, and don't worry if this is a little confusing at first, because if you do watch to the end of this video, I will explain it in an easy to understand manner that you will get.
When messages first enter AO, the user sends them to a messenger unit, or a MU for short. Users can pay the MU in whatever form that they want, be that tokens, fiat, or even perhaps cows. When it receives a message, the MU is responsible for finding the right scheduler, kind of like a sequencer but a little bit more complex, in the distributed scheduler network. Basically, it allows you to bring your own scheduler. Schedulers can take any form that the user likes. They can be either decentralized, staked, or even entirely different blockchains. You could use Bitcoin as an AO scheduler without modifying the core data protocol at all. Schedulers have 2 simple jobs: give a sequence number to each message, and ensure that it is uploaded to Arweave directly. After the scheduler has assigned our message to a slot and guaranteed its upload, the messaging unit will request that a compute unit, or CU for short, finds out the result of the operation. If the result contains another message, the process is repeated, pushing each new message in parallel around the machine. An AO token staking contract then keeps the behavior of each of these units in check and economically secure.
Now, if you didn't understand what he was going on about, don't worry. That entire diagram he just showed you can basically just be thought of as a little computer. But the key here is that every time a task is performed on that computer, all the important information gets uploaded to Arweave. And this means you can verify every single computation that has occurred. On top of that, people running the computers lock up some money in a staking contract. And if they misbehave or do the wrong computation, once again, we'll all be able to see it because all of that information is uploaded to Arweave, and they will lose some of the money locked up in their staking contract. So that's how one computer works on Arweave, but the key here is that because Arweave is infinitely scalable and can handle all the data you throw at it, you can in theory just build as many of those computers as you want, with all of that data being uploaded to Arweave so you can verify those computers are doing the correct thing.
This lets you build smart contracts that run like normal apps, extremely high throughput with great user experience. It also enables developers to build in an unconstrained environment. It lets you build things like large language models, that's AI, running inside smart contracts. You can even build things like decentralized recommendation systems and indexes for social media. This is the type of ability that will allow us to create trustless web services at scale.
We've been talking about Web3 for years now, but nothing has actually been built, and AO could be the key to actually allowing for the decentralized versions of Facebook, of X to actually exist. But not only that, also the decentralized versions of OpenAI. The AO computer also takes a modular approach, meaning that you can use any virtual machine or execution environment with it. And this is potentially a superior design compared to Arweave's major competitors, who are also trying to become the backbone of Web3, such as Filecoin and the internet computer. So you can build smart contracts and applications on top of Filecoin, but you will have to do so through their custom Filecoin virtual machine. There's no other way of doing so, which means you need to learn how to use it and all the programming languages that are compatible with it. Same with the internet computer. They have these things called canisters, and you will unfortunately need to learn exactly how to use them, how the execution environment works, and the programming languages that are specifically compatible with it. You can't just come along and use any language or execution environment that you want like you can on the AO computer. On the AO computer though, you're free to code exactly how you want to code. You're free to use any virtual machine or any execution environment. You can even use Filecoin's virtual machine or the internet computer's canisters, or you can use EVM or Solana's virtual machine, etc., or any combination of those and even more. And this is why the AO computer is so good, because you can build almost any type of application on top of it. So for example, you can code in Erlang, which is the same language a bunch of instant messaging services like WhatsApp use. You can build smart contract platforms like Ethereum using AO on top of Arweave that are fully scalable. You can build decentralized computer marketplaces like a Cache, which can be used in large language model transformer models, speech recognition, image manipulation, etc. This can basically host all of your Web3 needs. Now, the very last thing about AO is that it isn't fully out yet. It's on a public test net, but after they run a few audits and run the system a little bit more just to test it out, we should see it on mainnet sometime this year. So that's the premise of how Arweave works and the AO computer update. Now, the question I have for you is, how much potential do you think this thing will have? I mean, in just the first few days of the Arweave team announcing the AO computer, the price of Arweave skyrocketed from $8 all the way to above 30, and it is still climbing up 22% on the day. But this may still be nothing compared to what Arweave could do in the long term, because if Arweave does succeed in its mission and becomes the backbone of the entire Web3, storing all the information on Web3, but also handling all the compute on Web3 as well, including running the go-to decentralized AIs, the potential could be incredibly large. In fact, I'm incredibly bullish on AIs. If I'm honest, I think over the next few years or decades, AIs will revolutionize the world, meaning that whatever platform these AIs choose long-term to run their AIs on top of could become the largest cryptocurrency out there on the market. But once again, there are still risks because the entire Web3 space and decentralized compute is still in its infancy, so anything could happen, and who knows, maybe some other coin out there comes out with an even better solution that actually gets adopted. Now, if you do want to check out some of Arweave's major competitors in the decentralized AI sphere, I have already released 2 altcoin videos describing some of the best crypto AI projects that you should definitely watch. I'll link them in the description. But let me know what you thought about Arweave, like and subscribe for more altcoin reviews, and I'll see you soon. This video is not financial advice, read disclaimers on the screen.